So in today's video, we're going to be looking at the difference that you get in different airsoft motors. When you look at a standard versus a high-speed motor, what kind of performance differences are you going to get with those motors? So for today's video, we have three G&G motors. So these are all made by the same company, which will hopefully eliminate some variables with different manufacturers. We have an 18K, a 25K, and a 35K. So what does that mean? Well, this is 18,000 RPMs. And when we talk about RPMs in regards to motors, we're talking about revolutions per minute. So this will turn over 18,000 times per minute versus a 25,000 versus 35,000. So the question is, how does that interpolate into rounds per minute? One misnomer with motors, a lot of guys think you put in a faster motor, it's going to change the velocity of the BBs coming out of the barrel, which it does not. This just changes the number of BBs that you can get out of the barrel per minute. And it also interprets into faster trigger response, because with a electronic gearbox, when you pull the trigger, the motor has to spin up and move all the components inside of the gearbox in order to fire the gun. So the faster your motor moves, the less lag there is between when you pull the trigger and when the gun actually goes bang. So we're going to be starting off with these three motors and using them as our test bed. One variable in motor performance is going to be how many volts you're pushing through them. So we're going to look at two different batteries with these motors as well. We have an 11.1 LiPo made by Vulcan, and we have a 9.6 volt battery also made by Vulcan. These are probably going to be your two most common batteries. So we're going to look at the performance with each of these batteries and give you sort of an average performance rating with these motors so you can get an idea of what kind of performance you're going to get. The other variable we're going to look at is the spring that's in the gearbox. We're going to start off with a M100, and we'll probably also do an M120. So we'll look at the difference in the number of rounds per minute based on the spring that you have in the gun, because if the spring is heavier, it's not going to be able to turn over as fast and you'll get less rounds per minute. So we're going to look at all of those factors today to try to get an idea about what kind of performance you can expect with different motors. So for today's test, we have our standard test bed gun. This is just sort of a Frankenstein gun that I put together. It's a Vulcan body with a G&G gear set inside of the gearbox. This does have a quick release spring on it so that we can change the springs out fairly quickly. And we're using, I guess this is like a 200 millimeter barrel. So I'm not sure that the barrel length is going to have a vast effect on the performance of the motors. I suppose it could have a little bit, but I think that would probably be minuscule. So take that for what it is. So to start off, we're gonna start with an 18K motor, which is G&G's standard motor, and you can see by this everything metal is sticking to this. So if you're going to be doing anything with motors in your own shop, I would say do a real good cleanup job and get as much of the metal debris off of your workbench as you can, because these things, especially the high speed motors, have very strong magnets in them. They will suck up every last metal filing off of your workspace, and they'll stick to your motor and maybe even go inside of it and wreck your motor. So try to have as clean of a work surface as you can when you're working with these. The other problem that I've seen with these that I have problems with is the metal shavings will stick to the outside of the motor, and they stick out like little spikes, and you'll go and grab the motor and you end up with these splinters all in your hand. So that's one of the dangers, I suppose, of working with electric airsoft motors, especially high-speed ones. So we're going to go ahead and throw in the 18K. This is the standard motor to give us a baseline to work with here. Just going to line it up inside of the grip and get it all hooked up. There are faster quick releases I've seen for installing motors, and I'm kind of regretting that I didn't put one of those systems into this, because it would be really cool to be able to just drop it in and clip the motor in versus having to put these screws in it. But this is not that complicated of a procedure here. I'm hoping that the motor height will be pretty much set from the other motors that I've had in there. They may differ a little bit, so One thing that is going to also have an effect on your performance is setting the proper motor height for your gun. So we're going to start off with our test bed here with a 9.6 volt battery. We're going to just drop it into the PEC box. I'm using this so that we can swap out the batteries fairly quickly. So we just hook it up like that. We're running 0.2 gram BBs in the gun, and we're going to fire this through a Vulcan chronograph. I've tried it with the Evite chronograph as well, and they were pretty close as far as what it was rating the rounds per minute in. But for the sake of not being too confusing, we're just going to use the Vulcan chronograph and use these as sort of a relative rating of how many rounds per minute we're going to get. So we're going to fire it full auto through the chronograph, and let's see what we get. So we're getting about 727 rounds per minute with the 9.6 volt battery. So let's put down our results here. That was 727 rounds per minute. And now let's try it with an 11.1 battery and see what kind of performance we get with that. These are both brand new batteries, freshly charged, so I'm trying to eliminate another variable with the batteries. Obviously, the higher the voltage that you crank through it, the more rounds per minute you're going to get, and also how new the battery is. If it's a newer battery, it's going to get much better performance than an older battery, so that is something else to keep in mind. If you're using older, worn-out batteries, you are not going to get as good of a result with it. So now we are going to fire this through using the 11.1 volt battery. And you can hear it was much faster. We got 948 rounds per minute. So with the 11.1, we got 948 rounds per minute. So what we're going to do next is try different springs in the gun. Like I said earlier, we're starting off with an M100 spring. Because this is a quick change gearbox, we can easily pull it out and swap it out with an M120 and get an idea as to what kind of performance you get using an M120 spring. My gut tells me that the higher spring loading is going to cause the gun to not shoot as fast because it's going to take more power from the motor in order to turn the gearbox over, so you're going to lose some performance there, or at least that's my theory on it. We'll see if that holds up. So we've got an M120 spring using our 9.6 volt battery. Let's grab a fresh magazine here, and let's see what kind of results we get firing this through the chronograph. So with an M120 spring, we are getting 651 rounds per minute. So that's down from 727. Let's see what happens when we put our 11.1 volt battery in there and see what kind of performance we get using the M120 spring, if you're able to follow along with this. So we've got several variables here. One is the motor, one is the spring, and one is the battery. All three of them are going to have a distinct effect on the performance of how many rounds per minute you're going to get through the gun. And it's not just in the value of, how many bullets you can fire down range. It's also going to affect, the overall trigger performance so that you can get faster follow-up shots if you're firing in semi-automatic. So with the 11.1, we are getting 898. So what we're looking at here with the 9.6 volt battery, we went from 707 down to 651 when we changed from an M100 to an M120. We went from 948 to 898 when we used the 11.1 battery. So our next motor we're going to try is the 25K motor. And we'll have to swap out a few things real quick. Go ahead and take the battery and the mag out. We're going to go ahead and remove the motor, first thing. And For those of you that have not done this before, it's a fairly simple process. You have to make sure with your motor plate, this part here that holds the motor in, that there's not a little, some of them have a little spacer that holds the motor in. If you have one of those, make sure you don't lose it, because otherwise your motor height will be affected by the motor plate not having that little buffer in there. So there's our 18K motor. We're going to now grab our 25K motor. Get that in there, make sure that it matches up to where the wires go on it. Usually your red wire will go towards the front of the gun. Get these all hooked up. These are little spade connectors that go in there. These do have a tendency over time to eventually break, where it's bent on a right angle for it to fit into the motor. So it's a common failure point on these kind of connections, and it's like a good telltale thing. If you're ever going to use a gun, you pull the trigger and you have no response from it at all, that's usually the second thing that I'll check. The first thing I'll check is the fuse to make sure that the fuse is working properly, and then I'll also check those motor connections to make sure that they haven't broken. It's always a good troubleshooting system to go through. In fact, that may be another video I may do in the near future with going through guns and just troubleshooting the problem, because a vast majority of the time when people bring in guns for repair here, we see fairly common problems that are, you know, if you know a few things or you have some good troubleshooting skills, you can very quickly get through that and get your gun back up and running. So we're going to go back to our 9.6 volt battery, and we're going to go back to our M100 spring. So we're going to pop this guy out. We're going to put the M100 back in. This is a Vulcan M120 spring, I believe, although I did not test exactly which spring that is. And it's funny, with working with different springs, we've actually seen some of them, the lower quality ones, that after you shoot it a couple of times, the spring begins to compress and doesn't give you as good of a or as consistent of a result. So it's a good idea to use good quality springs. The best quality ones that we've been using lately are the SHS Rockets. Have been fairly consistent as far as our results with them. So once again, we're back to our 25K motor. We're going to start with a 9.6 volt battery and see how many rounds per minute we get with that. So let's get our magazine all wound up. That fed into there, and what do we get? So with that, we're getting 839 rounds per minute. So looking at versus the 18K motor, we went from 727 rounds per minute to 839 rounds per minute. So that was a distinct improvement in the rounds per minute. It was at least 100 rounds per minute faster. What happens when we go up to an 11.1 battery? There we go. So now we have an 11.1 volt battery with a M100 spring. What kind of rounds per minute are we going to get at this point? Bring that up. Wow, that was definitely faster. We got 1196 rounds per minute. So what happens when we step up to our M120? Well, good question. Let's find out. One of the fun things about having a shop like this with airsoft guns is you can build test beds like this, that you can easily do this. If you had like a standard airsoft gun with a stock on it, you'd have to disassemble the stock every single time in order to swap out parts like what we're doing here, which could be you know, a bit of a slower process, obviously. So now we've got our M120 spring. We're still using our 9.6 volt battery. Let's see what kind of results we get with that. And we are getting 631 rounds per minute. What happens when we go up to an 11.1 battery? What kind of improvement are we going to get? Obviously, the 11.1 is going to give you better performance, but the question is exactly how much are you going to get? There's always a bit of a compromise when you're doing this sort of thing between going from, higher performance as far as velocity or higher performance versus rounds per minute. It's nearly impossible to get both, although, you can, but you're going to be pushing so many, volts and amps through your battery and your wires that it's a good chance you're probably going to start overheating things. So it's usually a good idea to select which kind of performance are you going for. Either it's going to be high velocity or it's going to be high rate of fire. Trying to get both is really hard to get. So here we go. We have now got an M120 spring. And that is giving us 1167. So with the 11.1 volt battery, it's only dropping us about 30 rounds per minute. So there was a difference, but it was not huge. And we are now going to get our 35K motor. And you can see how strong the magnets are on these, that these really are going to pull onto anything that's either got a magnetic field or is made out of a magnetic material like metal. These suckers really want to pull on it, which is what gives you your higher RPM, is the performance that you get from those, I believe they're called neodymium magnets. You could also feel the difference when you turn the shaft on it. When you take the motor and you actually turn the pinion gear on it, you can feel the amount of resistance from the better magnets. So if you just want to, if you have a motor that doesn't have any kind of writing on it and you want to get an idea of it, how well it's going to work versus another motor, if you just manually turn the shaft and it feels like it's got more resistance on it, the chances are it's going to have a higher performance than one that has less resistance on it. So we've got a 35K motor. We're going to start out with a 9.6 volt battery. Get that all loaded up. Get that connected. And we're going to want to go, well, before we connect that, let's go ahead and swap out our spring. So we've got our M120 spring in here. Let's go ahead and pop that. We're going to put our M100 spring in there. Put our spring guide. You can see this has got a thrust bearing on the spring guide, which will give even more performance. All right, so once again, 9.6 volt battery, M100 spring, 35K motor. Let's see what we get. So we are getting 886 rounds per minute, which is up from 839. It's only a difference of about 50 rounds per minute. We're going to take our 9.6 out, put in our 11.1. That up. Got our BBs just readjusted, and what do we get? Wow. We are getting 1,420 rounds per minute. That's with the 11.1 volt battery. So you can see from going from a 9.6 to an 11.1, we went from 886 to 1,420. So that's a pretty significant jump in performance. So to put a monkey wrench in this, let's now go to our M120 spring. Switch this back out. Drop our spring in. Some people wonder, as far as the orientation of the spring when you put it into the gun, is that going to affect the performance of the gun? And the short answer is not a lot, not enough to worry about. I have tried it in several different orientations, and the difference is so minuscule, I almost think that it's not worth worrying about. So just one little bit of information that probably doesn't really matter, but anyway, that's what we do here. So we now have a 35K motor with a 9.6 volt battery and an M120 spring. What does that give us? We are getting 873 rounds per minute. So the only other thing left to do is try our 11.1 volt battery and see if we get any kind of difference, which my money is on yes. We are going to see a significant raise in the numbers of rounds per minute that we're going to get. So we've got our battery hooked up. So once again, 11.1 volt, M120 spring, 35K motor. What does that mean? 1407. Now I'm going to take this and make some charts, so hopefully we can make some sort of logical sense out of all of this. But I think it goes without saying, as you go from an 18K to a 25K to a 35K motor, there is a significant increase in performance. We went from 727 to 839 to 886 using the 9.6 volt battery, and we went 948 to 1196 to 1420 with the 11.1 volt battery. You could see we went so it's like about a 200 round per minute increase just by going from a 9.6 volt battery to an 11.1. So which is usually a cheaper upgrade to do if you're looking at the difference between buying a battery or buying a motor. I think an 11.1 volt battery is probably roughly half the price of buying a new motor. So if you don't have the money to drop into putting a 35K motor in there, you might want to just try a higher voltage battery, not just a bigger battery. When you're looking at the batteries, there's two things you're looking at, which is the milliamps and the voltage. The voltage, the higher you get with that, that is going to tell you how much faster it's going to run the motor. The milliamps is going to tell you how much longer it's going to run before it goes dead. So the milliamps, if you have like a 1600 milliamp versus a 2000 milliamp, it just means that the 2000 milliamp is going to run longer. It's not going to run faster. So for now, I hope this answers some of your questions as to what kind of difference in performance you get between different value motors. If you have any questions or you're looking into some of these products, feel free to stop into the showroom. We'd have all this stuff in stock. Or if you're looking at having these upgrades done for you and you don't feel like tearing your gun apart, it's definitely something that we can help you out with as well. So for here, this is what you're dealing with. See you next time. And don't let the bastards get you down.